So all those will be done in section 3.2, measures of variation. So in this, we will be mainly learning about the range, standard deviation, and variance. Okay, along with this, we will learn about CV, coefficient of variation. Okay, we will also learn about CV. Okay, now range. So I think we also learnt about this in chapter 2, I guess. So range is nothing but the maximum data value minus minimum data value. Okay, you have to subtract the largest data value with the smallest data value. That will give you the range. Okay, so for example, if I have data set like this 4, 5, 2, 3, 1, then my range will be equal to maximum minus minimum, which is the maximum value 5, which is the minimum value 1, right? So that gives me 4. So what exactly does this range do? That will give you the count of the numbers. So it is 1, 2, 3, 4. Okay, so this is the range. So I have a number between the range 1 to 5 and I have 4 numbers in that range. So that's the meaning of range. Okay, now the properties of range, it is not resistant, which means that it changes if there is a presence of outliers. Okay, what is resistant? If the data values does not change much, even in the presence of outlier, then we call that measure as resistant. Whereas in case of range, for example, if I do this as 100, 5 minus 100, the maximum is 100 here and the minimum is 2, I get 98. Do we have 98 numbers in this range? No, right? So this is a wrong answer. That means in the presence of an outlier, this is the outlier or say extreme value. So in the presence of outlier, the range varies, right? And that's why it is not resistant. That's one property of range. And one more property is I actually don't need all these values. For example, let me keep it as 1 here. Okay. Now, to find out range, I do not need all the values in the data set. I need only the maximum number and a minimum number. So I just need two values to compute the range. Okay. So if I give you maximum number is 5 and minimum number is 1, you can easily compute the range as 5 minus 1, which is 4. So you actually do not need the whole data set. That's one more property of range. Now, next is standard deviation. So standard deviation is denoted by sigma. We call this as sigma, and it is also denoted by small s. There are certain situations where we use this. So when you have a population data set, you would be denoting standard deviation with a sigma symbol. I call this as sigma. Okay. If you have a data value from a sample, if the data value denotes a sample, then I will represent standard deviation with a small s. Okay, but the formulas will be same. You don't have to worry about that. The formula of standard deviation is given by a square root of summation, right? Sum of all the data values, sigma. So this is called as summation symbol of x is nothing but the data values you have minus mu. What is this mu? What is this mu? No. Yes. This is nothing but mean, right? We denote this as x bar or also as mu, called as mu. Okay, so it is difference between the data value and mean, the whole square divided by capital N. So whenever you have a capital letters, so assume or just fix your mind that the data set belongs to population. Okay, this is for population. For sample, if you have a sample data set, then your standard deviation is represented by small s. The formula is saying square root of summation x minus, how do you represent mean for a sample? X bar. So I said mean is represented by x bar and mu. Mu is for population, x bar is for sample. So I will denote it as x bar, the whole square divided by so here the formula varies to n minus 1. Okay. This is one more formula. When you do not have mean x bar, when you don't have a mean given in the problem, or when you are not able to calculate the mean, then you can use this formula. Okay, but we will not be using this much. Okay, so concentrate on this and on this. Fine. So this is the standard deviation of a sample and also for a population. Properties. Is this resistant? It is not. Okay, so if there is a presence of outlier, then the value of the standard deviation will vary. So it is not resistant. That is one property, and it is never negative. It is never negative. Why? No matter what the data set, what is the mean, no matter what is it, but the standard deviation will never be negative. It is always positive or 0. Why do you think that is? Look at the formula here. It is square, right? So if you have some number x, and if you take a square to that, it will always be positive. For example, if I take x as minus 2 the whole square is positive 4. Okay, so if you have a square to a number, it will always be positive. So in the case of standard deviation, we have a square here, and hence it is always positive and never negative. Okay, so the larger values of standard deviation indicate that there is a large amount of variation. So here, as I said it can increase dramatically with presence of outliers. That's one more property. Now, sample standard deviation is a biased estimator. What do we mean by biased estimator? It means if your statistic lies around or with, like, if the value is similar to the parameter. What is statistic and a parameter? Oh my god. We have test 1 on September 22nd. Right, right. So statistics means statistic is nothing but a numerical value of a sample, and parameter is nothing but a numerical value of a population. So if the numerical value of a sample is nearer to the, or it is closer to the numerical value of a population, then we call it as biased estimate. Biased estimator means which will not have a value nearer to the population. If a statistic lies around parameter, we call that as unbiased estimator. And if a statistic lies around, do not lie around parameter, then we call it as biased estimator. Okay, so in this case, standard deviation is a biased estimator, and variance, we will be studying about that, is called as it is a unbiased estimator. Okay, now what is variance? Variance and standard deviation both are a similar type. So standard deviation, it will give you the variation of the whole complete data set, whereas variation will tell you how much it is varying. The amount of variation is given, the amount of variation or deviation is given by the variance. Okay, it is denoted by S square or sigma square. Okay, so you can easily say that what is S, right? Standard deviation of sample. So the square of standard deviation is nothing but your variance of a sample, and this is population. So square, standard deviation square of a population is nothing but your population variance. Okay, now again, the variance is not resistant, which means in the presence of outlier the result varies, and it is not resistant, and it cannot be a negative number because it is square of a standard deviation. Standard deviation is always positive, right? So the square of a positive number will always be positive. So what happens when variance is 0? When variance is 0, that means that the data values in a data set will always be same. If I have a data set like this with the same number, no variation, then I can say that variance is 0. And so as the standard deviation will always be 0 if you have a same values in the data set. And as I said the variance is unbiased estimator, which means the values tend to center around the value of a population. Okay, now let's see how to compute the range and standard deviation of these numbers. Range equal to maximum minus minimum, right? So which is the maximum number here? 26 minus 22. The range is 4. So now standard deviation is given by square root of summation x minus x bar. Now this is just a sample, right? It is not the complete cookies, so it is a sample data set, right? So I am denoting it by x bar divided by n minus 1 is the formula for standard deviation of a sample. This is for a sample. Okay, now let us create a table first and then we will compute that. I have x values, I need x bar, and it is x minus x bar and the square of that. What are the data values I have? I have 22, 22, 26, and 24. Now, I need x bar, which is nothing but mean. How do we compute mean? Right. So, add all the data values, divide by total number of data values, will give you the mean, which is 23.5. Okay. Now, we have mean. So x minus x bar is nothing but 22 minus 23.5. Okay, and again same 22 minus 23.5. So here x is 26 minus x bar is 23.5 and 24 minus 23.5. Find out the values. Minus 1.5, minus 1.5, 2.5, and then 0.5. Okay, so once you get the answer, you just have to square that. That is minus 1.5 the whole square. Minus 1.5 the whole square. 2.5 the whole square. And here it is 0.5 the whole square. What will be the value? No, do not round off. Okay, it has to be the exact value. Do not round off. 2.25, and it is same. What is 2.5 the whole square? 6.25. 0.5 the whole square? 0.25. Right. Now add all these values. That gives you the summation of x minus x bar the whole square equal to, add all the values. 11. Okay, now let us go back to our standard deviation formula, that is summation of x minus x bar the whole square root of whole divided by n minus 1, right? So square root of summation of x minus x bar the whole square is 11 divided by n minus 1. How many values do we have? 1, 2, 3, 4. 4 minus 1 is 3. So square root of 11 divided by 3 will be approximately 1.915. Okay. So standard deviation is, you can write as 1.1. So do not round off the standard deviation or the variance values. You have to write as it is, at least a 1 decimal place. Okay. So this is the standard deviation. Now, what will be the variance? How do you get that? Yes. So variance, I told you that variance will be equal to standard deviation the whole square, right? So what is standard deviation? It is 1.9. The whole square will be equal to 3.7. Approximately it will be equal to 3.6667. So you can write it as 3.7. Do not round it off, but you must have a 1 decimal place. So that's how you compute the standard deviation and variance. So to compute standard deviation, you have to compute mean and then subtract that with the data values, square the result, sum all the squares, and then divide by sample size. Okay? Now, before I get here, let's learn this. Range rule of thumb, which means that if you have a range, if the value of a range is given, then you can compute the standard deviation without the data values, without mean. Okay, so we will have this formula. Well, this is not the exact formula, you will not get an exact value of standard deviation, but it is an approximate value. If you divide a range by 4, you will approximately reaching the value for standard deviation. Okay, now let's say that we have a number line here and it is normally distributed, so mean, median, mode are equal. Okay, so this is my mean, which is represented by mu. Now if I say that we have a standard deviation within 2 range, This gives me the minimum value and this is the maximum value. This is the rule. This is the rule for range. Range rule of thumb states that we have a mu here. If that lies within the 2 standard deviation of the mean, then this will be called as the minimum value of a data set, and this is the maximum value of data set. This is the minimum and this is the maximum value. So the values which lie between minimum and maximum are called as usual values. The values which lie between mu minus 2 sigma and mu plus 2 sigma is called as usual values. Okay, now we have a value, for example, if you have a value which is less than this, okay, if you have a value which is less than this, it is called as significantly low values. If you have a value higher than or greater than maximum value, we call it as significantly high values or unusual high values. Okay, I call this as unusual high values. This is unusual low values. Okay, this is the range rule of thumb. Now, how do we get this formula? Now, what is the formula for range? It is maximum minus minimum, right? Now, I said to you that this is approximately minimum and maximum. So, I'm just using the approximate symbol here. Now, it is maximum minus minimum, right? So, what is maximum here? It is mu plus 2 sigma minus of minimum is mu minus 2 sigma. Just simplify this. Mu plus 2 sigma minus multiplied inside the bracket minus mu plus 2 sigma gives you plus mu and minus mu cancels. We will be left out with 4 sigma. Sigma is nothing but the standard deviation, right? So range is approximately 4 sigma or 4s. Standard deviation is also represented by s, right? So just rearrange the terms. You will get standard deviation approximately equal to range divided by 4. Okay, so if you have a given range and if you are not able to compute the mean, then you can use this formula, but it doesn't give you the exact standard deviation, it gives you the approximate value of standard deviation. Okay, that's the range rule of thumb. Let's get back to here. This is called as empirical rule for data. Now this 68, 95, 99.7 is nothing but your percentile or percentages. Okay, always if you want to know whether your bell graph or your histogram or your QQ plot, we will study about that later. So if those type of plot, if you want to know whether it is normally distributed or not, then it has to satisfy this rule. What is the rule? You have a mean here. If it is lying within one standard deviation, that is x minus sigma and x plus sigma, if it is lying within one standard deviation, it must have a percentage of 68. Percentage of 68. Okay. If it is lying within two standard deviation, it must have a 95% of data values in that range. It must have 95% of data values in that range. If you are data values are lie within 3 standard deviation, then the percentage is 99.7%. This is the rule. Okay. So the data values which lie within that range must be 99.7%. That is called as empirical rule for data. So we can easily say by looking at the graph that whether it is normally distributed or not. Okay. Now, here they are saying that they have a bell-shaped distribution, but they want us to find out. So they are already saying that it is a bell-shaped distribution, which means that it will obey the 68, 95, 99.7% rule, empirical rule. Okay. So we have a mean which is equal to 100. Standard deviation is given as 15. Standard deviation is 15. They want us to calculate the percentage of a data value between 70 and 130. Okay. So how can we do that? This is the x bar, which is equal to 100. Now x minus x bar minus s and x bar minus s. Right? Within one standard deviation, what will be the value here? 100 minus 15. 100 minus 15. 100 minus, this is plus 100 plus 15. 85, 115. Okay. Now the percentage between this, value must be equal to 68% according to the empirical rule. So 68% of data values lies between 85 and 115. Now extend the standard deviation because we need a values or data values within 70 and 130 range, right? So I'm going to extend it for 2 standard deviation. So x bar minus 2s and this is x bar plus 2s. Compute that. 100 minus 2 times 15. 2 into 15 is 30. So here it is 100 plus 2 times 15 is 30. This is 70 and this is equal to 130. Now we are getting the values which is mentioned in your question. So the standard deviation, the data values are lying between 2 standard deviation, which means what must be the percentage according to the empirical rule? 95%. Okay, so the answer here is 95%. So 95% of data lie between 70 and 130. Okay. Okay. So we learned about the range rule of thumb. Now let's do one example on that. So we have mean, which is x bar given as 24. Standard deviation s is equal to 2.6. Now first one is to calculate the minimum and maximum usual number of chips. So what is the minimum usual value? X bar minus 2 times s, right? As per the range rule of thumb, this is the minimum value. Mu is nothing but x bar. And what is the maximum number? Maximum usual value will be equal to x bar plus 2 times s. Now what is x bar? 24 minus 2 times 2.6. Tell me the value. Yes, 18.8. Maximum value will be 24 plus 2 times 2.6, which is equal to 29.2. So this is the maximum and minimum usual values according to range rule of thumb. So as you can see here, the advantage is there is no maximum value given, there is no minimum value given, hence we found out the range, right? We do not have a set of data values also. What we have is mean and standard deviation, that's all. So without having a data values, a set of data values, we can compute the range, the maximum value and a minimum value using the range rule of thumb. P. They are asking you that whether a 30 chocolate chips belongs to a usual number or unusual. So what is unusual? If you have a number, if the number is not between the range x minus 2 sigma and x plus 2 sigma. If the number is not in this range, then we call that number as unusual. So our work is to find out whether that 30 belongs to unusual or usual. Okay, so for that, let me draw a number line here. Now I know what is x bar, which is equal to 24. What is x bar minus 2s? 18.8. X bar plus 2s is 29.2. Now the 30 must lie between 18.8 and 29.2. So does the 30 belongs to this range? No, right? So it lies greater than 29.2, which means we will get 30 somewhere here. So a value which is lying between the range is called as usual. A value which is lying other than this is called as unusual. So this answer is yes, that's an unusual. So specifically called as unusual high value because it is greater than the maximum, so we call it as unusual high value. Okay. Now, coefficient of variation also called as CV. So what is the difference between variance and coefficient of variation? So variance we compare within the data set. In case of coefficient of variation, we will have two data set and we will compare the variance between two data set. Okay, that's the main difference. Do not get confused with the CV and variance. Variance and CV are not same. Okay. Now, the formula to compute coefficient of variation is given by this for a sample and this is for a population. Okay. Now again, do not round this off. You can round it off to one decimal place but not to an integer. It must have at least one decimal place. So now that we have two groups, A and B. We have two groups A and B. So here they are saying that the average price is nothing but mean, right? Average is also called as mean. So given information is mean, which is X bar, given as $50. In group B, the average, which is nothing but mean, equal to X bar, which is nothing but $100. Standard deviation S is equal to $5, and here standard deviation is given by $5. So standard deviation are same, the mean is different. How do you compute the CV? CV is given by S divided by X bar. CV is equal to S divided by X bar. 50 divided by 5 and 100 divided by 5. This is 10. Okay. So S is 5 and X bar is 5. Just shuffled it. Into 100 into 100% according to the formula. And S is 5, mean is 50 into 100%, 5 divided by 100 into 100%. So this will be 5% and this will be 10%. Now, how do you know how much it is varying? Now, what is the use of this? There is one note here which says that if your variation lie within 5 percentile, if the difference between the variation is within 5 percentage, then we consider that the two data set vary about the same. That means that there is no much variation between the data set. Now, what about the variation between these two data set, A and B? Covariance of A is 10 percentile, B is 5, which gives me 5 percentile. So it is equal to 5 and it is not greater than 5 percentile. So the data varies is, the two data sets are same. There is not much variation between the two data set. Okay. For example, if you had it as 12% and this is 12%, 12 minus 5 is 7, then we say that it varies, okay, because it is greater than 5 percentile. Now it is 5 percentile, which is in the range specified, so it is same. The two data sets vary about same. The variation will be same. So that concludes your chapter 3.2, section 3.2, measures of variation. Okay, now I'll give you an example. I have two groups, A and B. The data set will be 10, 60, 40, 30, 50, 20. This is 45, 40, 25, 30, 35, and 30. Now tell me the range of A, range of B equal to what? Range of A, range of B, standard deviation of A, and variance of A. Compute that and tell me the answer. Students in WebEx, anyone with the answer? What will be the range of A? Correct. 50 and 20. What is the standard deviation and variance? Standard deviation must be 17.1 and variance must be 291.7. Okay, you must be getting this result. So this concludes chapter 3.2 and I will see you all on Friday.